Alright, so in this video I'm going to be going over the 7.1 to 7.2 quiz review. This is mostly law of sines and cosines with a few area formulas. Really quickly I want to point to the formulas that I'm giving you. These are at the bottom of the third page. So this one is law of sines. These two are both law of cosines. They've just been rewritten. This one is area for oblique. And this one is Heron's formula for area. Okay. So then I'm going to go back to my front side. I need to decide what kind of triangle this is, or which kind of formula I'm going to use for this triangle. I have an angle, a side, and an angle. So this means I want to use law of sines. I know two of my angles, so I'm going to start off by finding my third angle, angle B. To do that, I'm going to take 180 because there's 180 degrees in a triangle, and I'm going to subtract the two angles I do know, 95 and 50. So 180 minus 95 minus 50 gets me 35. So I'm going to just write this off to the side so I don't lose it in my work, and then I'm also going to write it on my triangle. Now that I have all three angles, I can finally use my law of sines. I have an angle and a side that go together, because remember, angle B is across from side B. And then I can find either A or C. It doesn't matter which one I start off with first. Let me first set up my law of sines. So I write my side length for B on top, and then I'm going to write sine of 35 on the bottom. Then I'm going to start off with A. So I have my side length of A on the top, and my sine of 50 on the bottom, because that is the angle that corresponds to angle A. Then I want to isolate my variable, so I need to get this fraction to go away. I am going to multiply both sides by sine of 50. So that is going to give me 3 sine of 50 over sine of 35 equals side length A. So since my variable has been isolated, I want to go ahead and type this into the calculator. I want to make sure I'm in degrees. If I'm on a newer calculator, it will tell me. If I'm on an older calculator, I need to go check myself. To check, I will press mode, and then the word degree should be in black and solid. If not, I scroll down to it, press enter, and then second mode to go back home. Then I type in 3 sine 50, close my parentheses, and divide by sine 35. It wants angle or side lengths rounded to the nearest tenth. So this is going to be 4. Then I need to go ahead and solve for my side length C. So I start the setup the same. I have my side length for B on top, my angle for B on the bottom with sine. My side length C, I don't know yet. That's what I'm solving for. My angle for C is 95. So then I want to go ahead and isolate my variable. I'm going to multiply both sides by sine of 95. This gets me 3 sine of 95 over sine of 35 equals C. So I just want to go ahead and type this into the calculator. This one gets me 5.2. So whenever I'm solving a triangle and there's only one triangle, I should have 3 answers. Or I could also have no answers if it is one of the special side-side angle triangles. So we'll see that in a bit. Number 2 wants me to solve this triangle and round the nearest length at nearest tenth for the side lengths and angle measures to the nearest degree. I'm going to start by drawing out my triangle. It doesn't matter which angles I make A, B, or C. My side lengths are always opposite the angle I labeled. So B is 49 degrees, C is 115, and side length B is also 49. Then this one is 2 angles and a side. Also law of sines. One thing I want to point out is on the test, I will give you all of these different kinds of triangles, but they may be in different orders. So you might have the law of cosines ones on the front and the law of sine ones on the back. It's just going to be kind of shuffled around. But for this one, I have 2 angles, so I always want to start off by finding my third angle. I'm going to take 180, subtract 49, subtract 115. So I'm going to do 180 minus 49 minus 115, which gets me 16. I am going to write this off to the side again. Remember when I'm writing my angles to write them with the degree symbol. Then, now that I have my missing angle, I can go ahead and use law of sines. This side in between B and C is A, and this side in between A and B is C, because it's across from its angle. I'm going to start by finding my angle A. So my side length for B is 49. And then I have sine of 49, because that was my angle measure there as well. Then my side length for A, and this one is 16 degrees. So just like on the last problem, I want to isolate my variable. I'm going to multiply both sides by sine of 16. So if I rewrite this, I get 49 sine of 16 over sine of 49 equals A. So I wanted to go ahead and type this into the calculator. Oops, I forgot to divide. Which gets me 17.9, because I'm rounding to the nearest tenth. Then same deal, I want to go ahead and find side length C. So I'm going to start with the same setup. I have 49 over sine 49 for the matching pair of B. Whenever I have a triangle and I have an angle and a side that match up that's already on the given triangle, I want to keep that throughout the entire problem. So then I have C over sine of 115. I again want to isolate my variable, so I'm going to multiply both sides by sine 115. This is going to give me 49 sine of 115 over sine of 49, and this should give me side length C. So I'm going to go ahead and type this into my calculator. I have 49 sine of 115 divided by sine of 49, which gives me 58.8. So I am done with number 2. So number 3, I'm going to go ahead and start off by drawing my triangle. And let's see, I have B is 94 degrees, side length B is 4, and side length A is 25. So I have side-side angle. This one is law of sines. This is also the special kind of triangle where I can have one triangle, 2 triangles, or no triangles. So the way I determine if I have 2 triangles is my given angle is going to be acute, and the very first angle I find is also acute. Then I have to go check to see if I have 2. If I have one triangle, it will either, the very first angle will not be acute, so this one's not acute, Or when I go and they have two acutes, I can only make one triangle with the combination I have. And then I can also have no triangle. That gives me an error when I go to solve for the very first angle. So I'm going to set this up. I have a pair for B. So I have 4 over sine of 94. And then I want to find my angle A, so I know my side length is 25. And this time I'm looking for angle A. So I don't like having variables on the bottom. I'm going to multiply both sides by sine of A. I have sine of A times this fraction. I'm trying to get the variable alone, so I want to move the fraction over to the other side. The way I do that is I multiply by the reciprocal. So I flip the top and bottom of the fraction. I'm going to multiply both sides by sine of 94 over 4. So then I still have sine of A on my left. And now I have 25 sine of 94 over 4. I need to get rid of this function in front of A. The opposite of the sine function is the inverse sine function. This is always written in front because it's a function. So on my left side, the inverse and the function cancel out. So I have A equals sine inverse, and then everything I had on the right is in parentheses. So then I just need to go ahead and type this into the calculator. So I'm going to go second sine to get this with the inverse, and then I'm going to type that in. 25 sine of 94, close off the parentheses, divided by 4, close off the giant parentheses. This one gives me an error. It says domain. That one means there is no possible triangle. So my answer here is no triangle. Next one over here wants me to solve my triangle. Again, it gives me 3 pieces of information. So I'm going to draw it out. I have my angle C is 35, my side length A is 18.7, and my side length C is 16.1. So then what I want to do here is I want to do, well, first I want to decide what kind of triangle it is. I have a side, and an angle. So this one is going to be law of sines. So I want to set it up like I did the last time, and if I get an angle that works, I need to check to see if it's acute, and then check to see if I have 2 triangles here. So I am going to start off with the side and angle I know, that is C. So I have 16.1 over sine of 35. Then I want to find my angle for A because I have my side length for A. So just like before, I want to get the variable out of the denominator. I'm going to multiply both sides by sine of A. So this gets me sine of A times that 16.1 over sine of 35 equals 18.7. And then I want to get rid of this fraction, so I'm going to multiply by the reciprocal on both sides. On my left side, I'm just left with sine of A. And then I have 18.7 sine of 35 over 16.1. Then I need to get rid of the function sine. So I'm going to do the inverse sine. Then I just want to go ahead and rewrite my function. So now I'm just left with A on my left, inverse sine on the right of that whole fraction. So 18.7 sine of 35 over 16.1. Then I want to type this one into the calculator. Oops. Which gets me, this is an angle, so it wants angles to the nearest degree, 42 degrees. I am going to write this off to the side. Because this angle is acute and this angle was also acute, I need to check to see if there is two triangles. So the way I do this is I am going to take 180 and subtract this angle. This is because when I have this triangle drawn out, I can either have this angle right here, or I can have this angle right here. I'm checking to see if I can have that obtuse angle to make the same triangle. I am doing 180 minus 42. So let's check this on my calculator, which gets me 138. Then what I need to do is I need to make sure that this angle will work with my original angle and still be able to make another triangle. So I'm going to do 138 plus 35. Which gives me 173. This is less than 180. There are two triangles. So if you have this problem on the test and you only solved for one triangle, I would give you 3 of the 6 points this question is worth. Each triangle question is worth the number of answers they have. So let me go back to the front really quick. So if this was an actual test, number 1 would be worth 3 points. Number 2 would be worth 3 points. Number 3 would be worth 1 point because you only have one answer. This one is going to be worth 6 points, and then depending on how many answers each triangle below has, I'm counting the points based on that. So, next thing I want to do is, now that I know I have two triangles, I know this is my second angle. So my first triangle is going to get denoted with a sub 1. Then angle A sub 2 is going to be that 138. And this triangle I have right here is now going to turn into my first triangle. So all of those get my subs. And then I want to go ahead and solve this triangle like normal. Once I get all of my answers, I'm going to go back and solve the other triangle with changing A to 138. Everything I have written in blue will be the same for my second triangle because it came from the original problem. So, now that I have my second angle in here, I can solve for angle B1. I'm going to do 180 minus 42 minus 35. Which gets me 103. Then I need to go ahead and find my side length for B. So I'm going to use the sides that were given to me. I have 16.1 and sine of 35. Those match up for the C. Then I don't know my B1 side length. And I know my angle measure here is 103. So then I want to go ahead and multiply both sides by sine of 103. So I'm going to have 16.1 times sine of 103 over sine of 35. And this should give me side length for B1. I'm going to type this into the calculator. Which, this is a side length, so I want to nearest tenth, 27.4. Then I need to go ahead and do the same thing for my second triangle. So angle B2, I am going to go draw a rough sketch up above. So this triangle kind of looks more like this. And this time, my angle here is 138. So I need to solve for my remaining angles. For my second angle, B, I am going to take 180 minus the 138 minus the 35. Which gets me 7 degrees. Then, just like before, when I found my side length for B1, I'm going to find my side length for B2. I have the C's that match together. I have my angle on my side. So I have 16.1 over sine of 35 equals side length B2 over sine of 7. So then I want to go ahead and isolate my variable. So I'm going to multiply both sides by sine of 7. Going to rewrite this, and I get 16.1 sine of 7 over sine of 35. Should give me side length B2. Then I just want to type that fraction into the calculator. 16.1 sine of 7 divided by sine of 35 gets me 3.4, because this is a side length, so 1 decimal place. And I have finished this problem because I have found 6 pieces of information. Next one wants me to solve the triangle. It gives me 3 side lengths. So when I have 3 side lengths, this is law of cosines. And the very first thing I should do is solve for an angle. What I want to do here, when I have law of cosines, is I want to solve for my largest angle first. So I am going to, if I'm searching for an angle, let me get back to my picture and see what my largest side was. My largest side here was 7, so that is across from angle C. I'm searching for an angle, so I'm going to use the cosine of C formula down here. So that is going to be a squared plus b squared. So remember, this is a, this is b, and this is c. So I have 5 squared plus 6 squared minus c squared over 2 times a times b. Oops. So then what I want to do is I want to isolate my variable. I am going to find inverse cosine of both sides. And I am going to just rewrite this. And then I want to go ahead and type this into my calculator. So I'm going to go second cosine. And then, oops, this is not on the screen. I'm going to type in everything in the paper. I'm going to type my whole numerator in parentheses. So I'm going to have 5 squared plus 6 squared minus 7 squared divided by, and then my whole denominator I'm also going to go ahead and type in parentheses. So I'm going to have 2 times 6 times 5. I wanted this in parentheses. Which is giving me 78.4. This one again wants me to round to the nearest whole number for my angle. So 78 is my angle. Now that I have an angle and a side, I want to go ahead and use the law of sines to find a side length. So I am going to set this up. I have 7 for my side length of C, sine of 78 for the angle. I can pick either side when I have started off with all 3 sides. So I'm going to just start with A because it comes first in the alphabet. I know my side length is 6, and I'm searching for my angle A. So here I want to get rid of the fraction with my variable on the bottom. I'm going to multiply both sides by sine of A. This is going to give me 7. No, I wanted to write the sine of A out front. Sine of A times 7 over sine of 78 equals 6. Then I want to get the sine of A isolated, so I'm going to multiply by the reciprocal of this, which is sine of 78 over 7. I'm going to continue this down here. So I've isolated sine of A, and now I have 6 sine of 78 over 7. I need to get rid of the sine function, so I take the sine inverse. This is going to give me A equals sine inverse of 6 sine 78 over 7. Then I want to go ahead and type this into my calculator. Which gets me, this is an angle, so it's going to be 57 degrees. This was for angle A. Now that I have two of my three angles on my triangle, I can go ahead and just subtract from 180 to get the third. So I have 180 minus 78 minus 57. I can type this on my calculator, which gets me 45 degrees from my remaining angle. My last triangle for me to solve is something I need to draw out. I have A, B, C. My side length A is 8, so across from my angle A. My side length for B is 9, across from my angle B. And my C is 123. So this one, I have side angle side. This is, again, law of cosines. This one, since I have an angle given to me, it makes more sense to use the first set of law of cosines. So I'm going to use this one. The angle I had was C, so I'm going to use the formula on the bottom. I don't know my side length for C, so I have C squared equals A squared, so 8, plus B squared, which is 9, minus 2 times my A value of 8, times my B value of 9, cosine of my angle, which is 123. Because my left side is squared, I want to take the square root of both sides. So I'll rewrite what I have. I have C, and then the square root of 8 squared plus 9 squared minus 2 times 8 times 9 times cosine of 123. And then I just want to go ahead and type that whole thing under the radical into my calculator. So then I have 8 squared plus 9 squared minus 2 times 8 times 9 cosine 123. And then I just press enter. This is a side length, so I'm going to round to the nearest tenth, which is 14.9. And I'll just write this off to the side. So now that I have a pair of an angle and a side, what I want to do is I am going to use the law of cosine, or law of sines. So I'm going to set it up with the side and angle I know. I have 14.9 over sine of 1. Ooh, that 123 does not look so good. And then I need to find the shorter side length when I was given side angle side. So my shorter side length went with 8. So I'm going to find my angle for A first. Then I just need to use the law of sines to solve. So both sides are going to get multiplied by sine of A. This is going to give me sine of A times that fraction, 14.9, over sine of 123 equals 8. I don't like that fraction with sine of A, so I'm going to multiply by their reciprocal. This is going to give me sine of A equals 8 sine of 123 over 14.9. Then my A needs to be completely isolated, so I'm going to take the inverse function. This is going to give me A equals sine inverse of 8 sine of 123 over 14.9. Then I just want to type that into my calculator. Oops, 14.9. This is an angle measure, so I'm rounding to the nearest whole number, which is 27 degrees. I have 2 of my 3 angles for this triangle, so I can take the third one and subtract from 180. So I have 180, and I'm going to subtract the angle I was given, which was 123, and the angle I just found, which is 47. Oops, 123. Which gets me 10 degrees. And I have found my 3 missing pieces for this triangle. Okay. Moving on, this one wants me to find the area of the triangle, and I have 3 side lengths. This one is going to be Heron's formula, because it has the 3 side lengths. Oops, that is way off the screen. So, this one I first need to start off by finding my S. This is 1/2 of all 3 of those side lengths added together. So I'm going to type that into my calculator. I have 1/2 of 5 plus 12 plus 9, which is 13. Then I'm going to plug into that formula. So I have the square root of 13, and then times 13 minus 5, times 13 minus 12, times 13 minus 9. And then I just type that whole thing into the calculator. So 13 times 13 minus 5, times 13 minus 12, times 13 minus 9. What does it want me to round to? The nearest square unit, so whole number. This is going to be 20. And then I actually have units here. Inches, because I'm in area, squared. And then the last one wants me to find the area of the triangle. If I draw this one out, I have 20, 25, and then my angle in between, which is 30. This is side angle side. This one is area for oblique. So then I just need to use this formula down below. My angle I was given is C, so this part of my formula is what I want to use, 1/2 A times B sine C. So 1/2, my A side length is 20, my B side length is 25, and then I'm going to do sine of C, so sine of 30. Oops, that was off the screen. And then I just type this into the calculator as is. So 1/2 20 times 25 sine of 30, which gets me 125 degrees. I mean 125, not degrees. This is units. So centimeters squared, because it's area. So like I said, if this was the actual test, remember to put your degree symbols. Number 1 would be worth 3 points. Number 2 would be worth 3 points. Number 3 would be worth 1 answer. Number 4 would be worth 6, 2 triangles with 3 answers each. 5 would be 3 points. 6 would be 3 points, and then these 2 area formulas would be 1 point each.